Hello everyone, welcome to the Spintangle. This is the lecture 7 on mathematical physics, in which we will be discussing on three important methods which are called, say the first method is called trapezoidal rule. This is trapezoidal rule. The second method is called Simpson's 1/3 rule, and the third method is called Simpson's 3/8 rule. These are the three methods of obtaining an integration. Okay, these are the methods by which we used to obtain integrations. So let's take a coordinate axis, and I will be describing how to do this kind of integrations. Okay, say this is a say this is I'm taking a curve. Okay, I am taking a curve. Say this is the curve, and this is the curve. Okay. You have to perform a integration. The integration will be performed within this limit. Say you have a limit. Say this is the starting point, say A, and this is the ending point, say this is B. You have to perform the integration. What does the integration means? If there is a function associated, the function, say the function is given as f of x. Therefore, the integration of the function will be given by integration a to b fx dx. This is nothing but we know integration is what? Integration is the area under the curve. Okay, integration is area under the curve. That means this region. Okay, say this is the region. This is the region. Okay, say I'm doing this thing. This is the region. You have to calculate the area of this region. Okay, you have to calculate the area. Therefore, I am writing this thing here is area under the curve. Area under the curve. Okay, this means, just wait. Okay, this means you have to calculate this area under the curve by three methods. Okay, these are not the accurate methods. These are so-called approximation methods, which are mostly used in computer programming, mainly used to determine the area under the curve or to perform the integration. Okay, that means we are going to the area. Okay, so I am writing the integration again. So integration is given by integration a to b f of x dx. Okay, here what is the range? The first thing you have to do is the range division. Okay, what is the range division? You have to, I am writing this thing, let the range be divided into n equal parts. Okay, each of with h. Say this is h. Okay, this means what is h here? You have to calculate the h by this formula. Say the upper limit minus the lower limit upon the n. This is the required formula we will be requiring in case of determining the h. Okay, now you have to, the second step is make the table. make the table. How to make the table? In case of making a table, you have to do, say you are writing x terms here, and their corresponding fx terms will be written in this side. Okay, this means if you are writing x naught here, therefore here will be the value of fx naught. If x1 here, therefore the value of fx1 will be here, and here if x2, therefore fx2 will be here, and so on. And if you are going to put xn, then here will be a fxn term. Okay, now what is x0 here? X0 is, I am writing this x0. This x0, I am changing the last wait just wait. This is nothing but this is the lower limit. Okay, this is what the lower limit plus the width. This is what the lower limit plus 2 times the width, and so on it goes. Okay, and this becomes, and the very last term will be what, the lower limit plus, because this is the nth term, you have to use nh. Okay, the n times the width. This is nothing but the upper limit. So as you have divided this thing, say as you have divided in equal parts. Okay, say you have a here, you have b here, you are going to going from a to b, that means you have equal parts. Okay, the last part will be what, the entire thing will be what, the upper limit. Okay, the entire thing will be upper limit. This means the lower limit times the n times, say these are 1 2 3 5 6 times, this will be, b will be what, b will be, say b will be a plus 6 times the width, say these are equal widths, h h h h h h. Okay, and the a was the very initial term, that's why I have written a here. If it is 0, then put 0 here. Okay, if this is not 0, therefore you have to put the value of this thing, and plus 6 times the width in this case. If there are n, n partitions, if there are n partitions or n compartments, then you have to plug this thing here, that b is equals to a plus n times h. This is the ultimate thing. Okay, from this formula, the above mentioned formula, that this, we can easily write this thing as that h is equals to b minus a upon n. Okay, this is what I have written earlier. Okay, this is so up to this thing, the three process will be similar, and I am writing the required formula for the individual three process. Okay, let's take the formula for trapezoidal rule. See, to perform each and every case, first you have to make the table. If you are not making the table, then you will not be able to do this thing. Okay, so formula for trapezoidal rule. This is one of the easiest formula. It is integration will be what? Integration will be equal to width by 2 first term plus last term and 4 times all intermediate, sum of all intermediate terms. Let me write sum of all intermediate terms. This is all. This is the trapezoidal rule. We will be discussing a problem at the very end of this lecture, and I think there will, all things will be cleared. Okay, so for Simpson's 1/3 rule, I will be what? I will be equal to h upon 3 first term plus last term plus here it will be a 4 the sum of say odd values of y. Okay, sum of odd values of y, sum of odd y's, odd y's means say y1 or what y are what y, you can write this thing as these are the y's, that fx equals to y's. Okay, this means let me write this thing here. So this is the y0, this is the y1, this is y, this is the ultimately this is the y, this is y2, this is yn. Okay, you can write this thing as y, and the formula is completely given in the y format. 4 times sum of odd y's plus 2 times sum of even y's. This means we say y2, y4, okay, and so on, y6, and odd y's means y1, y3, and so on. This is nothing but this is the Simpson's 1/3 rule. Okay, now going to the next, that Simpson's 3/8 rule. For Simpson's 3/8 rule, the formula for integration will be 3h upon 8. Here it is a y0 plus yn, that is the first term and the very last term, and 3 terms which are not multiple of y3. Okay, say what is this, the term which are not multiple of y3, that means say y1, y2, you are omitting y3 and you are writing y4, y5, say y, so you are omitting y6 because y6 is a multiple of y3. Okay, y6 is one of the family member of y3. Okay, that's why I am omitting this thing, and so on and so on. These are plus 2 times terms which are multiple of y3. Okay, these are the important and so called important formulas. Okay, now let me elaborate these things and before going to the problem. Okay, say when to use trapezoidal rule. You have to remember this thing, and firstly I am writing this, when to use Simpson's 1/3 rule and when to use Simpson's 3/8 rule. This is, you have to remember this thing, that for any value of n you have to use the Simpsons for any trapezoidal for any value of n, for any values of, what is Simpson's 1/3 rule? When n is the multiple of 2, therefore you have to use Simpson's 1/3 rule. And when to use Simpson 3/8 rule? When n is the multiple of say 3. Okay, you have to remember this thing. Now I am going to the geometrical fact. On the curve. Say, what does trapezoidal rule means? Trapezoidal rules means this is not the accurate area which you will be obtaining by directly integrating this thing, but this is a approximation formula so that you can point this thing, figure this point out and figure this point out. You are allowed to connect them up. Okay, so you can see the area under the curve will look like the area under a trapezoid. Okay, this is the trapezoid. This is the trapezoid. This is the area. So in case of trapezoidal rule, you are missing this thing. You are missing this area. You are missing this area. That means what? That means trapezoidal rule is approximate and okay, it is close to the original integration, close to the real value, but not the real value, okay, of this integration. This is the ultimate thing of trapezoidal rule. And what you have to do in case of Simpson's 1/3 rule. Okay, in case of Simpson's 1/3 rule, you are allowed to draw a very middle point. This is the point, and you are taking an extra point, and then you are connecting this thing. You are connecting. I'm not right here. Sorry. Okay, this is a straight line. And this is also a straight line. Okay, that means what is the area of this thing? This is the area in case of Simpson's 1/3. This is the area. So this is more accurate than the trapezoidal rule, which has been discussed earlier. Okay, so in case of Simpson's 1/3 rule, here we can also see that this area is also not the accurate, but okay, it is finer than the trapezoidal rule. Okay, that means you have to plug another formula, that is, let me remove this thing. That is called Simpson's 3/8 rule. Okay, Simpson's 3/8 rule is one of the most clear area. Just wait. Okay, one of the most accurate area you can see. Say, okay, I'm zooming this thing. Wait, just for a while. Okay, let's check this. Okay. In case of Simpson's 1/3 rule, what you have to do? You have to plug another 2 points. Say this is a point. Say this is a point. Okay, and draw some lines there. So what you have to calculate now? Okay, just wait. Okay, now you are allowed to perform this thing, the area under the curve. Okay, I think this is getting more correct. This is the more correct area. Okay, this is the area of this thing, and the area will be of this thing, and this is the area of this thing and area of this thing. Okay, these are the individual areas got collected when, and they give the accurate result more than the trapezoidal rule and Simpson's 1/3 rule. So what we can see from this thing, that Simpson's 3/8 rule is the most accurate rule for obtaining integrations. Okay, so This is the Simpsons 3 by 8 rule, and the Simpsons 3 by 8 rule is one of the best method of obtaining integrations. Okay, there will be direct method for obtaining, and why we are too much worried about this thing, because these are the methods used to treat the integrations by graphical method. Okay, by solving graphically. If you are given a graph and you have to plot things up, and now you have to do the integration, then by using this kind of formulas you are allowed to do the integrations. Okay, so our problem is given that evaluate the integration. This integration is given. This integration should be solved by trapezoidal rule, Simpsons 1/3 rule, and Simpsons 3 by 8 rule, and compare the results. Okay, compare the results even with the original result. Okay. Okay, so let's take first step. Okay, the first step, step 1 is what? Calculate the width. How to calculate the width? Calculating the width is given by h is equals to b minus a upon n. What is b here is the upper limit, that is 6, and what is a here is the lower limit, that is 0, and I am taking there are 6 compartments, that is n. Okay, this means h will be what? H will be 1. This is what? This is the width. Width is 1. Now what we have to do is the step 2. In the step 2 we will be doing that the table. Okay. The table is what? Before making the table, I am writing this fx equals to y equals to 1 upon 1 plus, I think, x square plus 1 over 1 plus x square. What is that? 1 plus x square. 1 plus x square. I am writing this thing. Okay, so in the table what we are going to do, put x in this line and put y in this line. That y means fx. Okay, y means fx. Okay, so from starting from the a value, that is equals to the lower limit, and we will be going to the upper limit, that is 6. By step, what is our width length is 1. That means the second position will be what? 1. The third position, I am writing this 1 here. The third position will be what? 2, then 3, then 4, then 5, and 6. Putting 0 in the fx formula, in this formula, what does it become? 1 by 1, that means 1. Putting 1 in this formula, that means 0.5. The half means 0.5. Okay, for 2 value, that will be what? 1 upon 5, I think so. This means 0.2. Okay, 0.2. Put this thing on this formula, and you will be getting this. You are allowed to use calculator in the examination hall, or you will be given a virtual calculator to calculate, so that you will be able to do this thing easily. Okay, so what you have to do now for 3, what will be there? 3 is 9, 10, 0.1, I think so. And in case of 4, I have written this thing. Okay, what is 0.4 here? 0.4 means, sorry, what is 4? Put 4 here. 16, 1 upon 17. 1 upon 17 is what? 1 upon 17 is 0.05, I think so. 0.0588. For 5, it will be 1 upon 26. You can write this thing, or you can write it in fraction. Okay, 0.385. For 6 value, this will be 1 upon 37. Okay, 1 upon 37. What is the value of 1 upon 37? This is equal to 0.385. 0.027, I think. So I am correct. I think I am correct. There will be a 0.0385. Okay, this is 0.0385. Okay, write this thing carefully. Okay, these are the corresponding values. I am clearing this thing out that this is the value y0, this is the value y1, this is y2, this is y3, this is y4, and this is y5, and this is y6. This is the last value of our calculation. Okay, now I am moving to the formula. First, what we have to do? First, we have one formula, the trapezoidal rule. By trapezoidal rule, what we have here? By trapezoidal rule, what we can do? Say this integration is given as 0 to 6 dx upon 1 plus x square, and the formula was what? H by 2 y0 plus yn. Here yn will be what? Yn will be y6, because the last y is what? Y6, and 4 all other terms, other y's. Okay, intermediate y's, other y's, whatever, rest of the y's. Okay, this means in this case h is what? 1 by 2. H is 1, and there is a 2 for arbitrary 2. Okay, that means what is this? Y0 plus y6. What is y0 here? 1 plus y6 here is what? 0.027. Okay, 0.027 plus, in case of trapezoidal rule, I think there is a 4 or 2. I think, let me check this thing out. Okay, there is a 4. So what we have to do here? So 4 and other y's. What are the other y's here? Other y's are say y1, y2, y3. Put this thing out from the table. Y1 is what? Let me check this thing out. Just wait. Y1 is 0.5 plus 0.2 plus 0.1 plus 0.0588 plus 0.0385. Solve this thing out, you will be getting the value of the integration. Okay, solve this thing. Please let me solve this thing in calculator. Okay, I'm calculating this thing. Just wait for a while. This will be 1 plus 0, 1 plus, just wait, 0.027 plus 4 times 0.5 plus 0.2 plus 0.1 plus 0.0588 plus 0.0385 divided by 2. I think in the trapezoidal rule there is, I have written a wrong formula here. Okay, so make it correct. Let's write this thing here 2. Okay, write this thing here 2. So here will be 2. Okay, here will be 2, and this is all 2. By putting this 2, what we get here? 1.4108 as the result. Okay, now going to the Simpson's 1/3 rule. Simpson's 1/3 rule. What is the Simpson's 1/3 rule? That the integration will be solved by Simpson, that 0.026 1 by 1 plus x square, here will be a dx. The solution of this thing was given like this: h upon 3 y0 plus y6 will be here plus 4 into all, I think so, all in the formula let me check. Y1 here will be y1 plus y3 plus y5 odd wise and 2 into even wise. What are the even wise? y2 plus y4. That means put the values here: 1 upon 3 y0 plus y6 value, put the value of y0 and y6 in this formula of 4 into y1 plus y3 plus y5 y2 plus y4. There will be the answer I have calculated earlier. Okay, the answer will be I think let me calculate this thing. 1 by 3. What is y0 here? Y0 is 1. Okay, y0 is 1 plus y6 here is 0.027. Okay, plus this is all, and now what we have to plug here, that y1 plus y3 plus y5, that 0.5 plus 0.1 plus 4 into 0.5 plus 0.1 plus what was y, correct, y5 0.0385, y5 is 0.0385 and 2 times y2 plus y4. Y2 plus y4 is what? y2 is 0.2 and y4 is 0.0588. Okay, this is all. Let me calculate this thing, or you can calculate this thing. Okay, I'm not calculating this thing. Okay, now calculate the Simpsons 3 by 8 rule. Okay, what was our 3 by 8 rule? That integration is 0 to 6 1 upon 1 plus x square dx. What was our 3 by this? In the very front there will be a 3 by 8 term upon times h. And what was our 3 by 8 rule? Our 3 by 8 rule is given as y0 plus the n term is y0 plus y6 will be here plus 3 into y1 plus y2, omitting y3 here and writing y4 here, plus y5 here, and here it will be a 2 times y3, because there are the terms which are not multiples of y3. Okay, so I am omitting this thing here and I am putting this thing here. Okay, so this is the solution, I think so. If you are able to do this thing, there will be a 3 by 8. What is y0 plus y6? Put this thing out. Okay, put this thing out. I'm not doing this. Put this thing out, and finally you will you can see that the results will be some, that in case of trapezoidal rule, say you have something 1.4 1.4, I think. What was that in case of trapeze? 1. In case of trapezoidal rule, what was 1.4108? In case of Simpson 1/3 rule, you have some result, and you, in case of Simpson 3 by 8, you have also some result, and you have to make this thing check. You have to make this thing checked by the original result. Or what is our original result? What is our original result? Original result is given by 0 to 6 1 upon 1 plus x square dx. Okay, this is the integration. How to solve this kind of integrations? This kind of integration is solved by that if you are given that dx upon a square plus x square, it is solved by tan inverse x by a. Okay, this is, you can write this thing here, tan inverse x by a. That means what is x? X only. What is a here? A is 1. That is equal to 0 to 6. That means tan inverse 6 plus tan inverse 0. I think this result will be like, let me check this thing, let me check my copy, 1.4056. okay, this is the original result. And um, and relate this result with each of the cases, and you can see the deviation from the actual result, the value of this thing. Okay, so in this case what we will be seeing that the trapezoidal rule is the most accurate rule in this case. Why in this case trapezoidal rule is the most accurate case? Because you are having a tan theta and a tan theta graph. Okay, tan theta is what? Is nothing but a straight line. Okay, nothing but a straight line. So tan theta gives that the, by changing theta I will make this is tan theta means that m, what is this m? Inclination. Okay, inclination, tan theta for straight line. So I am concluding this thing for straight line. For more straight line, I am writing for more straight line, trapezoidal rule is more, trapezoidal rule will give more accurate results. Okay, and for more, for curved lines, say curved lines, Simpson's 3/8 rule gives the more accurate result. Okay, this is all. So let me check this thing. I will be giving a homework in the comment box. Okay, I will be giving a homework on the comment. Say you can solve this thing. Say this is 0, this is 1, this is log x dx. Solve this integration by these three kind of formats. Okay, these three formats: the trapezoidal rule, Simpson's 1/3, and Simpson 3/8 rule. This is your homework. Okay, so that's all. Thank you for staying with us. Share the video and subscribe the channel, like the video. Okay, thank you.